What is going on, and welcome back to another episode of I Coach Nutrition Radio. For those of you that are watching this episode here right now, I apologize in advance for the sunlight coming into my office. For those of you that are just listening, obviously no interruption for you. But today we're going to be diving into the topic of, can eating too little actually damage your metabolism, right? So we're going to explore kind of the truths and fallacies, if you will, of what you've referenced as metabolic damage. Okay. So there's a lot of discussion in the fitness industry about, whether crash dieting can cause metabolic damage. And so what we're going to dive into in this podcast is, essentially kind of separating fact from fiction. I'm also going to teach you exactly why crash diets might be linked to struggling to maintain your weight in the future, right, after doing so. So despite working out consistently and intensely, plus eating carefully, you're not losing weight, or not losing it as fast as you would like or expect. Or you were losing weight consistently until recently. Now you're stuck, right? And even though you're working as hard as ever before. Or when you were younger, you were super fit. Maybe you did fitness competitions, maybe you did crash diets, but now, even when you put in the same effort, you just can't seem to get as lean. Is my metabolism damaged, right? So this is a question that clients ask all the time, okay? And so the question really comes back to, can months or years of dieting do some kind of long-term harm to the way the human body processes food? And so the quick answer is not exactly, right? But we got to expand here. So gaining and losing body fat can change the way your brain regulates your body weight. And so to understand this, right, we need to explore how human metabolism actually works, right? And then from there, we'll talk about whether the metabolism can actually be damaged, okay? So we're going to look into the first topic here of energy balance. So the laws of physics still apply here, right? And so you need a certain amount of energy in the form of calories to stay alive, as well as to move around. You can get this energy from food, or you can retrieve it from stored energy, right? Like your fat tissue. So in theory, if you eat less energy than you expend, you should lose weight. If you do the opposite, right, you eat more energy than you expend, you should gain weight. So in other words, changes in body stores equals energy in minus energy out, right? And so we should use the term body stores deliberately, as it represents the tissues available for breakdown: fat, muscle, organ, bone, etc., and excludes water, which can change body weight independently of energy balance. This relationship between energy in and energy out is called the energy balance equation, and it's the most commonly accepted model for calculating a person's energy balance and how much weight they'll lose or gain over time. So while the energy balance equation determines body weight, it doesn't tell us much about body composition, which is influenced by things like sex hormone levels, macronutrient intake, especially protein, exercise style, frequency, intensity, age, medication use, genetic predisposition, and more. So understandably, people get really frustrated and confused with this energy balance equation when the numbers don't seem to add up, or the results don't match their expectations. And this is a good lesson, right, about the importance of adjusting your expectations to match observable reality, right? And it's a fair frustration. Most of the time, the numbers don't add up. Importantly, this mismatch between expectation versus reality is not because the energy balance equation is wrong or is a myth. Nobody's body defies the laws of physics, even though it seems like that sometimes, right? It's because the equation is more complicated than it sounds, right? There's many factors that affect the energy balance equation, and they aren't mutually exclusive. So what you do to energy in affects what happens to energy out, and vice versa, right? And so we've heard eat less, move more, right? And this is a good start, right? Most of us could probably benefit from eating a little less and getting a little more daily activity, but that advice alone isn't enough. It doesn't take all of the complex, interesting factors into account. So let's take a look at some of these factors, starting with the energy in part of the equation. So energy in is trickier than you think, right? Reason number one, number of calories in a meal likely doesn't match the number of calories on the labels or menu. This might sound hard to believe, but it's true. The way companies and even the government came up with the calorie and nutrient estimates was incredibly complex and rather imprecise and centuries old. And so as a result, food labels can be off by as much as 20 to 25%. And even if those food labels were correct, the amount of energy a food contains in the form of calories is not necessarily the amount of energy we absorb, store, and or use. So remember that the food we eat has to be digested and processed by our unique bodies. And the steps involved in digestion, processing, absorption, storage, and use, as well as our own individual physiological makeup, can all change the energy balance game. So for instance, right, we absorb less energy from minimally processed carbohydrates and fats because they're harder to digest. And we absorb more energy from highly processed carbohydrates and fats because they're easier to digest. Think of it this way. The more processed a food is, the more digestion work is already done for you. For example, research has shown that we absorb more fat from peanut butter than from whole peanuts. The researchers found that almost 38% of the fat in peanuts was excreted in the stool rather than absorbed by the body, whereas seemingly all the fat in the peanut butter was absorbed. In addition, we often absorb more energy from foods that are cooked and are chopped, soaked, blended, right? Because the processes break down plant and animal cells, increasing their bioavailability. So when eating raw starchy foods like sweet potatoes, we absorb very few of the calories. After cooking, however, the starches are more available to us, tripling the number of calories absorbed. Interestingly, allowing starchy foods to then cool before eating then decreases the amount of calories we can extract from them again. This is mostly due to the formation of resistant starches. And finally, we may absorb more or less energy depending on the types of bacteria in our gut. And so some people have larger populations of bacteroidetes, right? Which is a species of bacteria, which are better at extracting calories from tough plant cell walls than other bacteria species. And an interesting example of this whole process at work is USDA recently had researchers ask test subjects to consume 45 grams, which is about 1.5 servings of walnuts daily for 3 weeks. What they found was that on average, people only absorbed 146 of the 185 calories of the nuts. That's 79% of the calorie content on the label. In similar research, people also absorbed only 80% of the calories in almonds and 95% of the calories in pistachios. Beyond the average, there were individual differences. Some people absorb more of the energy in the nuts, while some absorb less, likely due to the different populations of bacteria in their large intestines. In the end, by eating a diet rich in whole, minimally processed foods, the number of calories you can absorb can be significantly less than what you expect. Plus, they require more calories to digest. Conversely, you will absorb more calories by eating lots of highly processed foods, plus burn fewer calories in the digestive process. And in addition, highly processed foods are less filling. They're more energy dense, and they're more likely to cause overeating. So since the number of calories someone thinks they are consuming could be off by 25% or more, their carefully curated daily intake of 1,600 calories could be 1,200, or it could be 2,000. So this means energy in equals actual calories eaten minus calories not absorbed. So as you can see, there's a big margin of error for energy input. Even if you're you're a conscious calorie counter, right? This doesn't invalidate the energy balance equation. It just means that if you want to have an accurate calculation, you probably have to live in a metabolic lab, right? And so for most people, that's not going to happen. So energy out varies a lot from person to person, right? The energy outside of the equation, again, which is energy burned through daily metabolism and moving you around, is a dynamic, always changing variable. So let's break it down. There are 4 key parts of this complex system, okay? Number 1, you've got your resting metabolic rate, okay, or RMR. RMR is the number of calories you burn each day at rest, right? Just to breathe, think, and live. This represents roughly 60% of your energy out and depends on weight, body composition, sex, age, genetic predisposition, and possibly, again, the bacterial population of the gut. So a bigger body in general has a higher RMR. For instance, a 150-pound man might have an RMR of about 1,600 calories a day. A 200-pound man might have an RMR of about 1,900 calories a day. And a 250-pound man might have an RMR of about 2,200 calories a day. So RMR varies up to 15% from person to person. And if you're that 200-pound person with an RMR of 1,900 calories, another person just like you on the next treadmill might burn 286 more or fewer calories each day with no more or less effort. Okay, number 2, thermic effect of food, otherwise referenced as TEF. So this may surprise you, but it takes energy to digest food. Digestion is an active metabolic process, right? Ever had the meat sweats, right? Or felt hot after eating a big meal, especially one with lots of protein? That's TEF. TEF is the number of calories you burn by eating, digesting, and processing your food. This represents roughly 5 to 10% of your energy out. In general, you'll burn more calories in your effort to digest and absorb protein, 20 to 30% of its calories, and carbs, 5 to 6%, than you do fats, 3%. And as noted before, right, you'll burn more calories digesting minimally processed whole foods compared to highly processed foods. All right, number 3, physical activity. Okay, physical activity is the calories you burn from purposeful exercise, such as walking, running, going to the gym, gardening, riding a bike, etc. Right? Obviously, how much energy you expend through physical activity will change depending on how much you intentionally move around. And then number 4, non-exercise activity thermogenesis, aka NEAT. NEAT is the calories you burn through fidgeting, staying upright, and all other physical activities except purposeful exercise. This too varies from person to person and day to day. And so the best way to track this is through tracking your steps each day. And so this means energy out equals resting metabolic rate plus thermic effect of eating plus physical activity plus non-exercise activity thermogenesis. So each of these is highly variable, which means the energy outside of the equation may be just as hard to pin down as the energy inside, right? And so while the energy balance equation sounds simple in principle, all these variables make it hard to know or control how much energy you are taking in, absorbing, burning, and storing. So the entire equation now looks like this, right? Changes in body stores equals actual calories eaten minus calories not absorbed minus resting metabolic rate plus thermic effect of eating plus physical activity plus non-exercise activity thermogenesis. So when you try to outsmart your body and it outsmarts you back, right, the equation is more complicated than what it can see. Right? And so even if all the variables in this final equation above were static, the energy balance equation would be complicated enough. But things get crazy when you consider that altering in any one of the variables causes adjustments in another, right? Seemingly unrelated variables. And this is a good thing, of course, right? Because our human metabolism evolved to keep us alive and functioning when food was scarce. One consequence, though, is when energy in goes down, energy out goes down to match it. You burn fewer calories in response to eating less. Not in everybody, right? And not perfectly, but that's how the system is supposed to work. That's how our bodies avoid unwanted weight loss and starvation. It's how humans have survived for 2 million years. The body fights to maintain homeostasis. Likewise, when energy in goes up, energy out tends to go up too. You burn more calories in response to eating more. So to illustrate this point, here's how your body tries to keep your weight steady when you take in less energy and start to lose weight. Thermic effect of food goes down because you're eating less. Resting metabolic rate goes down because you weigh less. Calories burned through physical activity goes down since you weigh less. Non-exercise activity thermogenesis goes down as you eat less. And calories not absorbed goes down and you absorb more of what you eat, right? And so this response is particularly modest at first, but the adaptation really ramps up as you lose more weight. If you're starting out lean and trying to get super lean, right, this occurs even more. So if you think about kind of this equation now, right? Changes in body stores, right? We've got essentially, the first part, right? Actual calories eaten minus calories not absorbed, right? So the actual calories eaten dramatically reducing this, right, can lead to decreases in calories not absorbed, right? It can also lead to decreases in resting metabolic rate, thermic effect of food, physical activity, and non-exercise activity thermogenesis. And so in addition to these tangible effects on the equation, reducing actual calories eaten also causes hunger signals to increase, causing us to crave and maybe eat more, right? So the net effect leads to a much lower rate of weight loss than you might expect. And in some cases, it might even lead to weight regain. So to add insult to injury, right, a rise in cortisol from the stress of dieting can cause our bodies to hold on to more water, making us feel softer and less lean than we actually are. Right. And this is just one example of the amazing and robust response to trying to manipulate one variable, right? In this case, actual calories eaten. Then there are there are also other similar responses when trying to manipulate each of the other variables in the equation as well. Right. And so, for example, research suggests that increasing physical activity above a certain threshold by exercising more can trigger increased appetite and more actual calories eaten, decrease calories not absorbed as we absorb more of what we eat, decrease RMR, decrease need, right? So again, this equation starts to get more and more and more and more complicated, right? And in the end, these are just two of the many examples I could share, right? The point is that metabolism is much more complicated and interdependent than most people realize. And so therefore, trying what used to work for you or relying on calorie counting often won't get you the results you want, right? As your energy balance evolves, so much your strategies for losing body fat or maintaining your weight. All right, so understanding energy balance means setting better expectations about body change, right? And it's important to note that if you have lots of body fat to lose, many of these adaptations, like lowered RMR, physical activity, NEAT, etc., don't happen right away, right? But as you become leaner, this adaptive thermogenesis kicks in. And it's also important to know that how your metabolism reacts to changes in energy balance will be unique to you. Right. And so how much you can lose or gain will depend on your age, your genetic makeup, your biological sex, if you've had relatively more or less body fat and for how long, the medications you're taking, the makeup of your microbiome, and probably a whole lot of factors we don't even know about yet. But let's try to simulate how this could work. Right. And so there were a group of scientists at the National Institute of Health that studied the data from people who have lost weight. And what they did is they created a mathematical model that represents how weight and fat loss actually happens in the real world. So in this example, right, let's start with a 40-year-old male with a starting weight of 235 pounds and a height of 5'10". We'll call him Frank. Right? Frank works a desk job and is only lightly active outside of work. This calculates that he needs 2,976 calories of energy per day to maintain his current weight. By knocking off 500 calories per day, his intake drops to 2,476 calories daily. And he doesn't plan on changing his physical activity. Now, you probably heard someone that you probably heard somewhere that a pound is equivalent to 3,500 calories, which means that if we take away those 500 calories from Frank, every day he should lose 1 pound per week, right? 500 times 7 days equals 3,500 calories. He should end up at 183 pounds after 1 year of consistently eating 500 fewer calories every day, right? According to this math, then he would weigh 0 pounds within 5 years, which should raise some red flags, right? But we know it doesn't exactly work this way in real life. At the end of a year, Frank gets on the scale, he's 205. What the hell, right? That's 22 pounds more than I should be. Frank rages to his wife, Maria, who smiles knowingly, right? She's 40 as well and has been trying to lose weight since having 2 kids in her mid-30s. Tell me about it, she says. I've lost and gained the same 10 pounds over and over, even though I've been exercising and eating pretty healthy. Then they both think, maybe I should just try that juice cleanse after all, right? My body is obviously broken. Nope, nobody is broken. Don't hit that juice cleanse just yet, right? Instead, Frank and Maria could both benefit from a clear understanding of how weight loss actually works. Then they set appropriate behavior goals and have realistic expectations for their progress, right? And so Frank and Maria, they decide against the juice fast and enroll in one-on-one coaching, right? And at the end of the year, Maria only, right, lost a total of 7 pounds, but has gained 5 pounds of muscle, which means she lost 12 pounds of fat. Her firm arms and glowing skin are the envy of other moms. Frank is down to a fit 185 pounds and trying to figure out how to convince Maria that he should buy a mountain bike. So, does dieting damage the metabolism? Despite what you may have heard, no, losing weight doesn't damage your metabolism. But because of the adaptations your body undergoes in response to fat loss, to prevent that fat loss, in fact, energy out for those who have lost significant weight will always be lower than for people who were always lean. Rather, losing weight and keeping it off is accompanied by adaptive, metabolic, neuroendocrine, autonomic, and other changes. So these changes mean that we would expend less energy, around 5 to 10% less, or up to 15% less at extreme levels, than would we be predicted based on just weighing less. And so, unfortunately, because of this adaptive response, someone who has dieted down will often require 5 to 15% fewer calories per day to maintain the weight and physical activity level than someone who has always been that weight, or even less, potentially, as we learned earlier, right? The RMR of people of the exact same age/weight can still vary up to another 15%. And so this means someone who has never actually been overweight might need 2,500 calories to maintain their weight, while someone who had to diet down to weigh that much may only need 2,100 to 2,400 roughly calories to hold steady there, right? And so we don't know how long this lowered energy expenditure lasts. Studies have shown that it can hang around for up to 7 years after weight loss or more. 7 years is as far as it's been studied. So that's kind of all the data that we have right now, but this likely means it's permanent, right? Or at least persistent. And so this isn't extra relevant for people who have, repeatedly dieted or for fitness competitors or something like that, right? Who have repeatedly, kind of fluctuate between being extremely lean and being overweight in the off season. And we don't have the data to necessarily back this up, right? At least to my knowledge, no one has actually studied it. But adaptive thermogenesis seems to react more strongly or more rapidly with each successive yo-yo of extreme body fat fluctuations. And so all of this explains why some people can feel like they've damaged their metabolism through repeated dieting, and why some experts suggest metabolic damage is a real thing. But nothing really has been damaged, right? And so instead of their bodies, have just ultimately become predictably more sensitive to various hormones and neurotransmitters. Their metabolic rates are understandably lower than predicted by various laboratory equations. So all that to be said, right, where does this leave us, right? And so the reality of it is that even people whose bodies resist fat loss or muscle gain can accomplish these goals, right? All physiological changes, including weight loss or weight gain, right? Body fat loss or body fat gain, and muscle loss or muscle gain require different efforts and amounts of time for different people, right? And so, even if your body doesn't resist, or even if your body does resist weight loss, you can still lose fat, you can still gain muscle, and you can still dramatically change your body. All right. So what do you do next, right? What are some tips here, right? Let's put this into application, right? So here's some of the best strategies for losing body fat and keeping it off. Eat plenty of protein, number one, right? Protein is essential when trying to lose weight, lose body fat for a few reasons. All right, number one, protein helps you keep that all-important lean body mass, which includes connective tissues, organs, and bone, as well as muscle. Number two, protein significantly increases satiety, right? Which means you feel fuller despite eating less. And eating more protein often causes people to eat less overall. And number three, just by eating more protein, you burn more calories because of the increased thermic effect of food. So, for example, if you're eating 2,500 calories daily, 15% from protein, 50% from carbs, and 35% from fats, which is the rough average for US adults, you're burning approximately 185 calories per day through digestion. So if you maintain your calorie intake, but increase protein to 30%, drop carbs to 40%, and whittle fat down to 30% or so, then your thermic effect of food goes up to roughly 265 calories per day, right? So again, that's almost 100 calories increased from that previous example there, right? And so for most active men, what should this look like? This should look like consuming somewhere between like 6 to 8 palm-sized servings of protein per day. And for most active women, this should look like 4 to 6 palm-sized servings per day. So, with that recommendation, obviously, it doesn't really matter how many times per day you eat. You just can think about kind of that protein recommendation there. All right, so that's protein, right? Number 2, eat a wide variety of fruits, vegetables, quality carbohydrates, and healthy fats. So vegetables are loaded with vitamins, minerals, phytonutrients, water, and fiber to help you fill up during meals and stay full between meals. It also helps you keep you healthy, right, and recover from your workouts. And so, at iCoach here, we will recommend that you eat somewhere between 6 to 8 fist-sized servings per day of these servings here for most active women, and between 4 to 6 size servings per day for most active women. The carbs will fuel training, right? They'll boost leptin, which is a super important hormone, and they will keep up with the sex hormones, right? As well as prevent feelings of deprivation there. And so the fats will keep up sex hormones. They'll also boost the immune system. They'll suppress excess inflammation, and they'll make food taste really good, right? So coming back to that, for most active men, this would be about 6 to 8 handfuls of quality carbohydrates and 6 to 8 thumbs of healthy fats per day. And for most active women, this would be 4 to 6 handfuls of quality carbs and 4 to 6 thumbs of healthy fats per day. So an easy way to think about that is to build out what I always reference as iCoach plates, right? You're filling up half your plate with color, vegetables or fruits or a combination of both, filling up a quarter of your plate with protein and a quarter of your plate with carbohydrates. Typically in the protein source, you are getting some healthy fats there as well, or maybe you're using an olive oil or avocado oil, or maybe you're adding avocado into that half plate color, right? Because technically it'd be a fruit, but you're getting mainly healthy fat from that. Those are just, some of those examples there. All right, so that was number 2. Number 3, adjust your intake as you plateau or to prevent plateaus, right? And so as your weight loss progresses, you will need to lower your calorie intake further to continue to progress. And so as your smaller body will burn fewer calories and your body is adapting to your diet, be ready, willing, and able to adjust portion amounts by removing 1 to 2 handfuls of carbs and or 1 to 2 thumbs of fats from your daily intake. Then reassess and continue to adjust as needed. Now, this hand portion recommendation or guiding system here, this can work great for some people, and other people are going to need to log their food on an app like MyFitnessPal, or maybe even weigh and measure and log their food on an app like MyFitnessPal. So there's lots of different ways to accomplish these goals and to get you results. Again, it just ultimately depends on the person, all right? What I will say is that research shows that we usually think we are eating less and exercise more than we truly are. So do an objective review of your actual energy in and out before assuming your body is blocking your efforts. And this is really where, actually weighing and measuring and logging your food is always going to be a lot more accurate than just using these hand portions. All right. On the other side of that, the research shows currently that the fitness trackers out there's typically between a 30 and 80% discrepancy in how many calories those fitness devices are telling you that you're burning versus how many calories you're actually burning. So instead of going off the energy out equation, focus on getting consistent with the intake side of the equation, and that way you can manipulate that based off of the results rather than trying to manipulate both at the same time. All right, so that was number 3. Number 4, understand, right, that this is complex, right? So many things influence what, why, and when we choose to eat, right? Too often eating and body size / fatness are blamed on lack of knowledge, lack of willpower, lack of discipline, lack of, or just plain out laziness, right? But in reality, food intake and body composition are governed by a mix of physiological, biological, psychological, social, economical, and lifestyle influences, along with individual knowledge or beliefs. And so one of the most simple ways to make your decision process easier is to create an environment that encourages good food choices and discourages poor ones. Right? And this can mean making changes to your daily routine, who you spend time with, where you spend time, and what food is readily available to you. But remember, right, that weight loss can and should be relatively slow. So aim to lose about 0.5 to 1% of your body weight per week, right? What this looks like for most people is about a pound, about a pound or two per week, right? And this will help to maintain muscle mass and minimize the adaptive metabolic responses to a lower calorie intake and resulting weight loss. So faster weight loss tends to result in more muscle loss without extra fat loss, as well as a larger adaptive response. All right, so that's number 4. Number 5, cycle calories and carbs. So for people who are trying to get quite lean, at some point, you can't just rely on linear dieting to get you there. By strategically cycling calories and carbs, you can help to limit how much the metabolism regulating hormone leptin drops or temporarily boost it back up. So attenuating the adaptive and hunger response there, right? And so, just a quick note here, this is definitely a higher level strategy for typically fitness competitors and elite athletes who need to get very lean, right? And so this is somebody that's trying to get to like 6 to 9% body fat for men, which the equivalent there would be about 16 to 19% for women. So it's not something for the average person. And to be honest, most of the clients that I work with, this is not a strategy that we use. All right, so that was number 5. Number 6, refeed periodically. Okay, and so when getting to extreme levels of leanness, even strategic calorie and carb cycling might not be enough, right? And so if you want to kind of have some higher level coaching here, a higher level strategy, you might want to employ some periodic refeeds to temporarily boost leptin and insulin and keep fat loss going. Again, though, this is a higher level strategy for fitness competitors and elite athletes, right? Somebody who's trying to get extremely lean, right? This is somebody that, kind of going back to the carb cycling or calorie cycling, somebody that's trying to get less than 6% body fat as a man, or somebody that's trying to get, kind of the equivalent there, less than 16% as a woman. Okay, so that was number 6. Number 7, do a mixture of resistance, cardiovascular, and recovery activity. Right, so resistance training helps you to maintain vital muscle mass, burn calories, and improve glucose tolerance. Cardiovascular exercise improves the health of your cardiovascular system. It helps you expend energy and can improve recovery. But don't overdo either one, right? You need both. You also need recovery work, right? Foam rolling, stretching, walking, yoga, right? All of this helps to maintain consistency and intensity with resistance and cardio training, making them more effective. And it helps to decrease stress, right? Which can lower which can lower cortisol, which also helps you lose body fat and keep it off. So aim for 3 to 5 hours per week of purposeful activity. All right, that was number 7. Number 8, find ways to increase NEAT, right? Non-exercise activity thermogenesis. That's what NEAT stands for. Even small increases in activity can account for hundreds of daily calories and therefore make a big difference in fat loss efforts, right? And so some ideas here, right? Get a stand-up desk, right? Or get a treadmill desk, right? Play with one of these little fidget spinners there, right? Pace while on the phone, right? Take the stairs, park your car farther away from where you're going, right? Go on a walk, right? Just make it a point to be more active, right? A great goal here would be to make sure you're walking at least 7,000 steps a day, right? The average American, they get about 2,000 to 3,000 steps a day. So that's the definition of living a sedentary lifestyle, right? So if you, again, meet yourself where you are, assess, right? Track it for a week, see where you're at, and then slowly start working that number up from there. All right, that was number 8. Number 9, develop a solid nightly sleep routine and manage your stress. All right, sleep is just as important to your success as nutrition and activity levels. Don't pretend that you can get by with less. It just simply isn't true. All right, you can tell yourself all day long that you're good on 5 hours, but the reality of it is you don't define human physiology. And science says that if you are a human, you need at least 7 hours of sleep, 7 to 9 hours. 7's the bare minimum, 9's optimal. Right? Often when people lower their stress, they lose a lot of body water. Right? Then they also notice that they have lost more fat as well. Right? And they may discover that chronic inflammation goes down, right? So all of these wins, right? And so this includes mental and emotional stress. Research on cognitive dietary restraint, right? Worrying and stressing about food shows that constantly and negatively fixating on what you eat or don't can have the same unhealthy effect as actually dieting stringently, right? So we need some stress, right, to actually help with progress and growth there, right? So you kind of got to find your sweet spot with that. All right, and then last but not least here, number 10, have some self-compassion, right? There's going to be meals or days where you don't eat as you should, right? And it's okay. It happens to everyone, myself included, right? Recognize it, accept it, forgive yourself, and then get back on track. Right? You are a product of what you do the majority of the time, not the minority, right? And not to mention, research actually shows that self-compassion and flexible eating is associated with lower BMI and a healthier body weight, as well as lower self-reported calorie intake, less anxiety and stress, and just a better overall relationship with food. So I hope this helped. This is, if you haven't heard about this yet, you will hear about it. This is something that's a very hot topic in the fitness, nutrition, health world right now. And so if you have any questions, please let me know. I'm more than happy to help. But I thought that this would be a useful podcast. Definitely pretty in-depth here, right? So any questions that pop up, drop them below, shoot me a message, comment, whatever. But I hope y'all enjoy this here on this lovely Sunday. I hope y'all have an amazing week going forward. And yeah, until next time. Thanks, guys.